Hello, this is developer log number 4 for GHGC, which is the prototype of a game I might make if the prototype turns out good. This, what you're seeing right here, is more or less where we were last time with number 3, and we had the grappling hook in there, swinging around on it, but you can tell it's juddering as you pull yourself in. And paying out is actually working alright there, but if you're not the right way up, it gets real confused. And basically Unity's physics is fighting my own little hacky code that I've written, and that was trying to do it with let's say cast the grappling hook and see, there should be a hinge joint here. Yeah, so that's one of Unity's sort of inbuilt ways of handling something that rotates around a point, which is what I was trying to do with the grappling hook. And it was a decent idea, but I kept playing around with it. This is as far as I got with that particular implementation. It never really got any better than this. I couldn't get it to retract well. There's no way to kind of shorten the hinge joint as you go that I could find. Let's load this one. Sudden jerk force to stop body falling beyond rope. Not working. Going to try modified velocity directly next. Revert entire project to that. And close this. And so it looks like fall from the sky. That's my grappling hook. You can see it didn't stop me falling in any way. These lines you see, there's a big red line, and if I started, actually I can probably just spawn. Yeah, you see a big yellow line. Sorry, white line. The white line is the tension of the rope, so it's showing where the rope is pulling me and how hard it's pulling. And gravity is obviously always pulling at the same rate in the same direction. And as you can see, this is my last try to kind of do it with real physics and kind of add forces manually and kind of play into Unity's physics logic. And as you can see, it's just hopelessly squishy. It just kind of, you can never get it to be properly rigid and hard. It's always just a little bit forgiving and bouncy. And if you increase the forces enough to make it kind of stop you hard, then you kind of bounce in the opposite direction. You're always massively overcompensating for things. It's really hard to get anything to stay stable and just do what you want it to do. So then go back to the history and let's see. That was okay. So this is the first attempt I did with just modifying the velocity of the body directly, which is a thing that I heard was kind of frowned upon. You're not really meant to do that, but it means I code how fast you are moving. I write down the equations and say, when you're on this grappling hook thing, here's the equation that gives your velocity. And look, it stops you immediately. And retracting is really, really sudden. Paying out is really, really slow. So when I'm holding down here to pay out, and then when you retract it goes crazy. And for a while I thought this was working, I thought I'd solved the whole problem, and then I realised, like, that thing, I'm still using a force to retract the rope and a force to pay it out. And this retracting force looks good, but actually when you look at it, like, I retracted all the way to the anchor there, and now it's long again. So something weird is happening there. What's actually happening is I'm only retracting it a little bit, but my force is so huge I go flying way past the actual desired rope length, and the rope is secretly going slack, but it's not really showing that. And then I'm kind of falling back down to where the rope was, so it's all a horrible mess. So I had to rethink that as well, and then eventually came up with, let's just skip all the way to my current version, assuming I haven't, messed with the version control in such a way that it's totally broken, which would be a disaster. I have backed this up, as I say, in a million different ways, and here we are on the actual current version. I'll make it bigger so you can see what's happening. Why didn't that work? Make it bigger. Make it bigger. Yes, here we go. And now the grappling hook, it's hard, and I've also made it so it only attaches to solid objects. I can't forecast it in mid-air, it just falls, which is hilarious. So I shoot it onto this building, latches on, and then I can pull up smoothly. And I'm spinning like a madman, but paying out and pulling up happen at the same speed. There's no overshoot. When I stop pulling up, it stops pulling up. And if I fall and latch onto this lamppost, I can swing like crazy. And this is it. This is like... it was hard to explain exactly what I was going for, but the second this was working, I'm like, yes, this is the motion I've been looking for. This is how retracting should work. This is how paying out should work. This is the kind of like hard, non-elastic rope I was after. This is the kind of not realistic pulling force, but extreme pulling force. Just something that really, really fucking works. When you pull up on this, you're never going to be stopped. You're always going to go up. And as you can see, it's really fast. This is my guy's 2 meters tall here, so this lamppost is rather unrealistically 15 meters tall, and then these buildings are like 40 meters tall or something. So climbing a 40 meter tall building in this kind of time, I'm pulling very hard there. Like to lift a 60-kilogram body that fast is a lot of force. But I'm not actually using forces, I'm just directly saying, hey, no matter how heavy I am, no matter what the forces involved are, just always lift me this hard. But I also need to use Unity's physics system to manage things like that, all that tumbling, all that colliding with things, all that, like, just the way a crate would work when you throw it around a room. You know, you'll see any game that has physics in it will have a box being thrown around a room at some point, and that's rigid body physics, and Unity handles that for you. But I needed all of that to still work, and I also needed to manually modify where the player is. This is no longer using Unity's hinge joints, I'm just using my own equations to figure out when the player should stop and how fast you should move towards or away from the anchor, and how that swinging should work. And that stuff's tricky. I had to look up loads of basic mechanics, stuff I hadn't studied since like GCSE physics, and then I also had to look up like degree level vector mathematics, which I had learned before, but again I'd also forgotten, and combine the two to get equations of tension and things like that. And it's actually working now, and it feels so fucking cool. So this is one of the I'm discovering loads of things from this, but one of the main ones is that this is going to be a game with a certain element of skill to it. I wasn't sure about that before. It's not, this thing I'm doing right now is really awkward because you can't see that side of the building because the camera doesn't follow you. And let's actually just take a quick diversion to see what happens if the camera does follow you. Hang on, I need to stop it from maximizing and then restart it so that we've got this here. Right, so here we are on the ground. One of the cool things you can do in Unity is you can kind of make an object a child of another one, which means it moves with it. So if I attach the camera to the player, then when I suck us up here, the camera tilts with us. So you'll see relative to the camera, we're always upright, and that means the camera is just like going with our perspective, and that's fucking horrible. Oh god. Oh god. Oh god. I'm sorry for what I've done. Oh, Jesus Christ. Yeah, so, I mean, the advantage of this method is that if I fall over to this side of the building, I can see that side of the building. So it's that's nice. But probably in the final thing, I won't have the camera actually rotate with you, because, Jesus. Oh, Christ. Yeah, let's take the camera back out of there. Hopefully that should... Oh, no, I can't. Okay, the camera's stuck now. Alright, we'll have to restart. But let's go full screen again. Yeah, so I'm experimenting with the feel, and this has taught me so many things. Like, A, it feels really good. B, there's a load of skill to using this. There's so many awesome tricks you can pull off with it. That thing I just did there was catapult myself over a building. This lamppost, so I just thought about this. It was a very, like, loose, vague idea in my plans of just, as well as these buildings you're climbing and trying to break into, if we wanted to give you something to kind of swing around, you can't really swing around a building because the building's in the way, but if you want to do a kind of loop-the-loop or kind of more traditional grappling hook tricks, then it would be good to have something that's kind of hovering in mid-air that you could latch onto. And in normal cities, things don't hover, and I still want this to be a game set roughly in the real world. So I was thinking of things that protrude forwards a little bit in the air, and a lamppost was quite a natural fit for that. And so I tried putting one in because I kind of had fun. Back when the grappling hook would latch onto the empty space, there were some cool things you could do with it. And now, for some reason, now that there's only one place you can latch onto in the middle of space, it's even better. It's really like satisfying to latch onto that in a way that it wasn't just latch onto empty air. And there's so many cool things you can do. There's like one cool thing you do with it. I mean, you can see I'm getting loads of momentum. That's because I'm pulling up on the rope as I'm swinging around it, and increasing my velocity towards the lamppost is basically doing the same thing as accelerating my orbit of it. It's actually a little bit like orbit physics. So if I can pull it off, one of the things you can do is I'm standing on a shorter building, and there's a taller building there, and in theory, you can use your momentum from one to get to the other. Didn't quite make it that time, but yeah, if you're really good, you can do that. So it's teaching me that there's going to be a high skill ceiling for this game. Like, the people who are really good at it, you know, if they do make this game, if it does end up being decent, the people who get really good at it will be dramatically better than the people who are just starting out with it. But most of these tricks will be just kind of like finesse things. They'll just be, you know, you can still get to the top of that building no matter how slow or bad you are, because you just shoot the top of the building and then climb up. And you can see I've got this little bit of fudged logic where if you get close enough, then it automatically pops you up to the top of the building. That would be like a clamber animation if you're an actual animated human here. But yeah, it's nice to know that there'll be loads of stuff to kind of play around with, and it will feel very physical, and it will feel very It's much sillier than I imagined. I was kind of picturing it quite realistic, and there are definitely sort of serious realistic things you can do, but there's obviously loads of potential for just really madcap, crazy acrobatic stuff. So that's awesome. I'm willing to roll with that. That seems fun. But that'll change, you know, the personality of who you are and stuff. I don't want you to be a super serious character if you're going to be doing stuff like this. Not that I was ever really going to write a super serious character. But yeah, it's super fun, and that's probably all I've got to show for the moment. I'm probably not going to try and talk you through the code for this. I'll show you it just so you can get a sense of how it's sprawled since then. But yeah, it hasn't really like bloated out control, but it's just there's so many steps to it now that it would just take me hours to explain it all. You can see that these are all the variables that I define and start up. So there's a lot of different things going on in it, and there's still that old function to measure where the cursor is in the world. That's really handy. There's a thing that's always looking at how far away we are from the anchor and how far we're moving towards it. All this code here is all about the swinging and the retracting, and the only kind of interesting, tricky, mathsy bit of it is that it has to change or fix or do things to your velocity towards the anchor. So where you're grappled onto, I want to make sure you don't move towards it if you're not retracting. And if you are retracting, I want to make sure you do move towards it. And if you're paying out the group, then I'm wanting to make sure you move away from it. But I don't want to affect any of your other velocity. So if you're already traveling really fast when you do that, I want to make sure you don't, break the rope, but I don't want to take away your forward velocity, because that would stop you in midair and that would feel really unnatural. So it's all about modifying these vectors in a way that doesn't interfere with their existing momentum. Which is actually, it's tricky stuff, but it's quite fun to mess around with. It's good, nerdy, physicsy, mathsy stuff. It's kind of using loads of bits of my education I haven't used for years and years and years, which means I've forgotten it all and have to look it up again. But it's nice to understand the physical world a little bit better. And then these are just kind of convenient things to. That's the tension of the ropes. That's how hard the rope is pulling towards the grapple point. That's code for ungrappling. This is all control stuff really. So this is like when you click. If you're already grappled, you should ungrapple. If you're not grappled, you should grapple. I've been saying the word grapple a lot this last week. And then that's for retracting and unretracting. I'm actually going to change the controls quite a lot, but I just need something in there to basically work with. And the result is super fun already, and I'm really enjoying it.